Hello and welcome to Fabricating Firewood. My name's Matt. It is July 4th, 2024, and this is going to be day 2 or part 2 of my manufacturing, fabricating of an actual firewood bundler. I'm also going to do a side hustle. When I was selling my flail mower today, I dropped it off, and the guy I sold it to has a part that guides the tractor into the implement that's kind of messed up, so I'm going to try and fix that for him as well. Not sure in what order, but when I start welding, I'll get to those. I left off yesterday with making the bracket that the front of the firewood closest to me will fit in. It's about 12.5 inches, which is fine. Customer gets a little bit extra, but this part's done. I'm going to have to get 2 pieces of square tubing that will mount on both sides, but I can't get that done until I determine how high it's going to be. I also got the back part of it done so that it can spin. So I'll put that out of the way, and now I'm going to, I think, work on getting the back part that the 1-inch round stock welds to. I'll get that cut. I'm not sure exactly which part I'm going to use, probably that heavier tubing, and then I've got some flat bar I'm going to weld to that for strength, so because it's just going to be attached to a thinner wall square tubing. So basically the square tubing is going to be welded to the face of the flat stock is going to be welded to the face of the square tubing, and then the round bar is going to be welded to the actual flat stock. That way there's no chance of it actually bending up and down because of the weight of the wood and the weight of the assembly that's going to spin, because it's actually going to be probably around 40-50 pounds all in. So I'm not 100% sure where I'm going to start. I think I just have to get in one baby step at a time. So I don't want to prematurely cut this rod. So there has to be enough plate sticking out, or I'm sorry, has to be enough of this round stock sticking out for the plate to mount to it. I'm going to review the photo real quick, see how far he had his out. He said there's no sense in reinventing the wheel. And it looks like it's out about maybe 1.5 inches. I don't think it's requires that much. I'd say that'd probably be a good enough distance to stick out. In his new version, there's only probably about, so that part is about 3 inches, so it's probably about 6-inch long piece, which is probably a good. I think his previous one was 9 inches and some change. So I think just as long as I have enough distance for the chain to clear, the sprocket to clear, and then the front plate. What I can do is actually not make it as deep, and I think as is it's 36 inches deep. I don't think it needs to be quite that deep. So I mean that's pretty deep, 36 inches. So I think I can make it a little bit smaller. So if I cut that at about 6 inches, that should be good. And you know what? Got 3 more feet of it, so it's not really that thin wall. It's 1/8 inch thick square stock. This is going to consist of the main frame, and it's going to be heavier. Number one, because, and I'm using the heavier materials primarily because I don't want someone coming along and saying, "Ooh, I want that," and then take it. It's going to be probably 150 pounds, I would say, and all in. I've got these to make forklift pockets, so this will be what it essentially sits on top of. Front to back, these will be I imagine front to back will be the feet of the thing, so that I can pull in the front or pull in the back, and then that way I can just weld the verticals directly to it without having to worry about using extra stock. So since these will be the feet, it'll be nice and heavy so it won't tip over, and it'll allow me to come and pick it up with my forklift with the tractor, front and rear, which I never plan on moving it except for using the forklift. So I'm also going to put some tie-down D-rings on this so that when if I do ever have to move it, I can strap it down to my deck over without having to worry about bending anything. So let's get to it. Okay, soapstone. I'm going to measure go measure the normal width, typical width that I keep my forks at, and then that's going to be how wide I make the feet, and determine if I go front to back or side to side. It is from the inside of my forks is 20.5 inches, and then the outside of my forks is 27 inches, and the outside limit of IBC cage is 36 inches. So typically, when I have my forks the way they're at, I can pretty much get anything I need picked up with that current setting, and I've never had to change it right now from the 27-inch outer width. So that being said, I would say that the inner section of this fork pocket would need to be at least 20.5 inches. Or let's say 20 inches. Maybe a half inch, which will give the outer 36 inches. So these will work perfectly. So by putting these at about 35 inches outer width, or let's just say, I'll just stick with the 20.5. So let's just say the outer width needs to be 35 3/4, which will give me the 20 inches, or 20 1/4 inches, which will allow me to just slip my existing fork configuration right in, and that'll give me 36 inches wide. So that being said, front to rear 36 inches will probably be about right, and that will put the let's see here. If I want to come in from the front of the bundler, the feet will have to be too narrow because it has to be 40 1/4 minimum. So I'm talking out loud here. So the outside dimension of the bundler needs to be about 40 1/4. That will give plenty of room for the mechanism to rotate around at 30 inches. And then front to back is 36 inches. So what that'll give me is, if I put them left to right, I have to come in from the side of the bundler with the forks to pick it up and transport it either side instead of the front or the back. That way I don't have to be, that way I get the actual width that I need, which means I'm going to have to cut these down because these are just drops that I got. They're 48.5 inches. So good thing about drops is they're cheap. Okay, so thinking out loud. So for the back, I've got these 1.5 inch pieces. They're 1/8 inch thick. I'm going to make this the top back plate. 2 of these sandwiched and welded with a 1/4 inch by 3 inch plate face so that I can weld the rod directly to it for strength. So 40 1/4, I need 2 pieces of this and a plate cut. So I'm going to go ahead and cut that. what I'm doing now is lining these up perfectly and then clamping it down so that I can pull the blade up right next to it instead of relying on a piece of soapstone to get me perfect. Now I've got to cut 3-inch plate. Now you could argue that you don't really need a plate going across the full width of the back, but I've got the steel, so might as well. So being as this non-aerospace alloy firewood bundler is going to sit outside for the rest of its life, once it gets finished and I test it out and it works to my satisfaction, I'm going to take it to Gale Enameling in Plainfield and get it powder coated. They will take it, completely sandblast it down, and then they will powder coat it. I am not concerned about grinding all of the mill scale off of it, because it really doesn't matter. It's kind of a moot point. All I'm worried about right now is getting it somewhat set for me to weld it and not have to worry about grinding everything down to make it perfect. The welds will penetrate the steel. I'm not worried about that. Typically I would weld I would grind down any spot where there's going to be a weld just so I get a good clean weld, but like I said, it is literally not that big of a deal because it's a firewood bundler, not an aircraft. Alright, time to set up the welder. Problem is I'm going to have to turn this fan off, which will make it a little bit warmer in here. If you missed my previous welding video, this stupid hat here is basically to keep the flying slag off of your head when it bounces and lands in between the strap or whatever of the helmet, the welding helmet. It tends to burn. And then the bill of this little stupid hat blocks the light from reflecting off the inside of the welding helmet. Well, like, why is it not working? It'd help if I'd plug this side in. Oh, it's hot in here. C5. Okay, so this will be the back side. The plate is going to be the front where the rod is mounted to. A little more heat. And this is too dark. Still too dark. Still too dark. God damn it. I can't see where I'm going. Oh, no wonder. There we go. Now it's too bright. I can at least see the work. Let's go up to about 8. Oh, nothing worse than sweat dripping down your face and tickling you. That's a crappy weld. So less feed. So let me show you the difference. I could not see the work down here. So it was all over the place. You can see how too much wire causes it to build up, and I'm going crooked because I couldn't see. And this is me just doing tests to get to where I could see, and every time I was going the wrong direction. And now you see, well, here's the same thing, but now you can see how it's obviously looking way better. So that's what I'm looking for right there. So I'll just grind these down and then weld those over. Because like I said, it's a firewood bundler. And no need to do a test weld on some scrap because this is all scrap. So let me grind these bad boys down quick. The goal is to have a weld that's the finished weld and not have to worry about grinding it down at all because it looks so nice. Okay, so I've got the 1.5 by 1.5 square tubing welded together and to the face plate where the rod is going to be mounted. So next, what I'm going to do is cut the rod and then weld it directly to the face of this. I am going to clean this off. Now this measurement isn't critical, just about 6 inches. I am going to try and pick the flattest side. So this is 1 inch diameter, cold rolled round stock. I need to go get my machinist square. Never mind, I got magnets. Oh yeah. Now the problem with magnets is that when you weld near a magnet, the flow wants to tend to go towards the magnet, so you gotta be careful. Trying to keep my hands as clean as possible. I'm gonna have to rub my eyeballs. So it's gonna be easier to take this into my bandsaw or my or sander, belt sander, and put a 45-degree on it. So I'll be back. So I have to get this right in the center, so it's not all cattywampus. It is exactly 40 1/4, so 20 1/8. It's gonna be my center line. And 1.5 inches. So I want this just slightly below the surface, so it's not touching, and I can tack weld it, and it doesn't matter if there's welds on the other side because it's going to hold this plate. It's going to hold this this block to the plate, and that's why I don't want the rod touching. So I can just center the rod over the lines. Make sure that's square. All right, so the clamp is holding the block to the plate. It doesn't matter if it's angled because if the block is holding the plate, and then this right here is being held into the actual block, so it's perfectly square with the piece. So I'm going to tack weld it on 3 sides, let it cool enough to pull it off so it doesn't tilt. Let me get you all up in here. Okay, so even though that this assembly is on the table sitting on top of welds and it's all at an angle, it doesn't really matter because I've got the clamp holding the block to the piece square, and then I've got the shaft raised up above, so it's not even touching the plate. It's about a 1/16 of an inch gap there. So right now, as long as the rod is clamped into the wedge of the block and then the block is clamped to the plate flat, this is perfectly square. So what I'm going to do now is tack weld the shaft to the mounting plate, let it cool a little bit, and then pop the clamp and the block off and then tack weld the other side, and then I can start welding around. And I'm going to do 2 layers of welds, probably 3, one around the actual chamfer, one on top, and then one on bottom. So this shaft will be triple welded directly to this plate, 1/4 inch. Don't necessarily want this wobbling around on me. I'll get her somewhat fixed in there. That boy ain't going nowhere. For now I'm just getting the slag off of the shaft and off the plate. Now the test. I'm going to go cool this off first before I put some bearings on it. Yahtzee. So let's see what kind of work I've done. So that is currently 4 9/16. That is. Well, I mean, it does wobble, so the bearings wobble. So I'm going to push down on this. That is 3 11/16. Push down on that. 3 1/2. So basically, it does wobble because the bearings. Yeah, there's a significant amount of play in the bearings, so it is. Let's see if I can measure. 20 9/16. 20 9/16. So it's square. Just that there's a lot of play in the bearings, but that will definitely do it because there's plenty of room from the outside. And I'm going to weld the face of the sides directly to the 1/4 inch plate. So now what I got to do is make the front plate. And I'm not welding the plate directly to that. I'm getting the 1 inch bushings, 2 of the 1 inch bushings, and then putting them on here and then welding them together and then welding so it has 2 bushings deep to hold on the plate onto this, and then I'm going to weld the plate to the bushings. So the bushings that I've got are, again, from Amazon, C-100 1 inch ID set screw collar steel zinc. So I'm going to put the screws on the same side. I'm going to have about a 1/16 inch gap between the spacers. if I put the screws on opposing sides, that will reduce the diameter because it'll push them in opposite directions. So that's the only reason. Typically, I would like to have a screw on both sides, but it's just holding the plate for the wood. I keep hearing things. It's just holding the plate for wood, but I want to be able to slide it on with ease. And since if I put the screws on opposing sides, it will pull it. It'll reduce the diameter of the collar on the shaft. So that's why I'm putting them on the same side. But I am putting a 1/16 inch gap in between the two bushings. It's driving me nuts. So that I can get a weld down in there without having it too big. I'm going to try it on the same setting because it is thick steel. I want to kind of get it somewhat pinned down so it's not rolling around on me. Man, this humidity and causing me to sweat is just really bothering me with my face. Just sweat running down the face, making it itch. And my nose is running because of my sinusitis. That tickles. Ugh. Willpower. These gloves suck. Now, I can't mess this up because these are the only colors that I have. Now I can start cleaning it. So the plate I got is a drop. Saved me a significant amount of money in having a piece cut. So I'm going to have to use my grinder to just basically go back and forth and cut it. I don't have a plasma cutter. Just one thing I've never gotten. And I don't have a commercial steel table saw, and it's too big to fit in the chop saw. So just going to have to make it by hand. I do like having this shipping container as a workshop because I can just blow all the debris out. But what I do miss is the air conditioning of my garage. I think the name of this welding table is a Certiflat, C-E-R-T-I, flat. Great table. Comes in a pallet with box. It's all flat, and then you weld it together. It's all laser cut, set up so that you can just tack weld it and then put it all together. It's a great table, and I ordered it and it came in, but I asked them if they could make me something custom for a reloading bench. Same exact thing, but just a smaller size. And they're like, oh yeah, no problem. And then about a week later, I sent them the dimensions, and they just ghosted me. So if you want to order something from them right off their website, you're good to go. But if you need anything custom, no matter what I did, call, text, because I was talking to the guy via text and on the phone. Call, text, email, didn't matter. It's like he got it in his head that he didn't want to do that custom thing after he said he would, and never heard from him again. But I did order some parts later, and they came right in. So order away, but don't try to get them to make anything custom for you because they won't, or didn't anyway then. So I opted for a 1/4 inch drop, and it just so happens that it was 12 inches wide, 25 inches long, meaning I paid a fraction of the cost it would have cost me to have them cut from plate steel. So pretty much all I got to do is draw a line and then use my grinder to just take swipes at it to cut it in half. But the 1/4 inch plate will resolve the issue of warpage. I noticed that Macamee, I think it is, Farms, the guy, can't remember his name, but anyway, I noticed that he had some issues with the warpage. That's why I got the 1/4 inch plate. And it's all about, as far as warping goes, if you're using the thinner plate steel or sheet metal, you want to tack weld it and then weld opposite, just like lug nut pattern. So just tack weld, tack weld, tack weld, let that cool, and then just come back and like do something else and then come back and put a little bead on it and just keep doing that back and forth, and that will mitigate some of the warpage on the thinner steels, but should not have that issue with this quarter plate. Guess I should make sure that this is square. 27 5/8. Yep. So, good to go. Before I go doing this, the front section is 12 1/2 from inside to inside. About 12 3/8, 12 5/16. Again, it's a firewood bundler, not aerospace shit. So I want to kind of make this the same. And I also need to figure out what I'm going to do for the sides and the bottom. I've got 2-inch, 1/8-inch plate. So I'll probably cut that and then weld that around. So I'm going to cut this at the smallest size, which is on the bottom, so because I can bend it out at the top. So 2 5/16. $12 5/16. Know what I'm talking about. Sharpen my soapstone. $12 5/16. Oh, no, I'm sorry. 2, 4, 6, 7/16. 12 7/16. Problem with soapstone is it doesn't make a really fine edge. Use this bar stock as my marking edge. Put this down just to confirm everything's good. On the inside, yep, good deal. I'm going to use this as pretty much a track saw, just to get it started so it's a straight line. Need my hammer. So once I got it clamped down, I can tap on this outside. Actually, it's moving anyway, so I need to be clamped on this. Alright, so I've clamped this as my guide to make it a track saw, basically, hold the plate down. And then I'm going to use this one to hold the plate down over here, so I'm not worried about it moving. All right, that's deep enough. What I don't want to do is start grinding into my table. And that took virtually nothing off. The trick is to keep it light, don't push, let it do its work. When you get about 3/4 way through, leave both ends open. So that you can do this right here. And not have to worry about it falling. Battery, one battery, struggle busing. All right, which side is the good side? 12 5/16. Huh. 12 5/16. So they're actually good. They're both the same. Best place and cheapest place I've found to get discs and these heavy-duty flap discs is from Harbor Freight, of which I need to get more of. All right, I changed the battery out. Grind this down so I don't slice anything. Battery would help. Okay, 12 by 12 and 5/16. So I'm going to use this 1/8 inch as the border. So I'm pretty sure stretch wrap is 12 inches. So this is 2 inches. That is 2 inches. So 16-inch long piece of wood minus 4 is 12. So that'd be right on. So I'm wondering if I might want to use something not as wide, maybe, because it'll be pretty close. I'm going to go in and see if I have some 1 inch. So I do not have anything narrower, but what I can do is offset. I can offset the 2 inch so that it's not on top of it or next to it. It's basically offset a little bit. And it'll give it a little strength because it'll have the back side corner welded as well. So I need to cut 3 pieces. Let's go the bottom one, and that is 1/8 inch, I'm pretty sure. 1/8 inch. So let's add 1/4 inch, so 12 1/4 inch to one piece. 12 9/16. The way I'm going to get the offset is I'm going to, so if it's 2 inches and I only want 1.5, so 16 wood, 12-inch roll, figure a 1/2 inch plastic, or the 12-inch roll of plastic, and then a 1/2 inch on each side. That'd be 13 inches, so 3 inches, it's 1.5 inches. So I'm going to take a 1/2 inch piece of stock that I have and set it underneath it and then weld it to raise the plate up. Suffice it to say that I would imagine you could get 36 to 40 inches of 1 inch to 1.5 inch wide by 1/8 inch or 1/4 inch bar stock. You wouldn't have to do this right here. But I got what was available in drops, which saved me a considerable amount of money. So to confirm, that's the wide side. And I want this right at the edge because I can clamp this directly to, if I wanted to. But what I'll do is push it back a little bit, make sure that's all flat, no bumps. So this will keep it vertical. And I just want to extend it past equally on both sides because the plate is going to be exactly 12 inches on the sides. It'll rest on top of this one and give it strength. This is good enough for eyeballing. Now, I can see that there's a little bit of a gap in that because this plate is probably bent a little bit, so I'm going to get a clamp and clamp that. I'm just going to tack it. So I can see that it's flat against the magnets, so it's vertical. This is raised up by a 1/2 inch square tubing. And I've got equidistant on each side, a little bit too much on one side. Too much. There we go. Pull it together. Make sure everything's square. And to test it, note to self, remove precision tools from welding table when welding. You don't get slag on them. Vertical, vertical, vertical. Okay, everything's good. What I'm doing here is just using the threads. I mean, it's not good on the brass threads, but I mean, I've been doing it for years and they still work, so. Knocking the slag off of the inside of the, what do you call that? Can't remember what it's called. Nozzle, off the nozzle. Hotter. Now again, remember the weld, the molten steel will go towards the magnet, so don't weld against the magnet. So I want to make sure that this is still somewhat straight. It is. So I will flip it over. Ah, dang it. Looks like it warped a little bit. And again, it's merely for a bundler. Oh, it's just in a little bit. All right. There we go. So I'm going to weld that a little bit. Notice that sound where it's and then at the same time. all mixed together, and it's not going hack, 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 hack. That's what you want to hear. When it starts cracking and popping, that's when you have an issue. All right, now I need to cut 2 pieces that are exactly 12 inches. The hell? Don't tell me that got bunched up. Crud. Where I got bunched up and cut, I don't think I'm out because I had a big old roll in there. Unless for some reason I am out. Yep, I'm out. Shucks. 30. I can go get another one. If you're wondering, I use a ProMig 175. I've had it for 17 years, and it's never done me wrong. I only just brought this welder out here a couple days ago when I started this project, and I have not brought all of my welding accoutrement out here yet. Here it comes. All right, back in business. Need to go get me another one of these. Get several. Actually, I sent my wife to get some replacements, and she came back with those 11 pounders, and I think it was the 15 pounders that I wanted. And what she said was that is literally the only ones they had. Literally the only 2 that they had was 2 11 pounders. And this was back during the pandemic when it was going on. And you couldn't get raw materials for anything. Yahtzee! So what I did there was weld the top. Oh, it's driving me nuts. I welded the top. Oh. Sorry about that. I welded the top opening so water wouldn't creep down in there and start rusting. Now it's going to get in behind it, but it has a place to go. Ugh, man, that's crazy. All right, now I have to locate the center of the back of this for the collar. People make fun of me for the way I say collar, like that's the color of yellow, and then collar, like the collar the round collar that you put on it. The collar. I don't know. Whatever. My wife is mainly the culprit that makes fun of me. Okay, I'm gonna go cool this down some with some water. There we go. Look at that. Perfectly square, flat. I'm gonna fix that. So that is 12 and a half, so 6 1/4 is going to be center. And that is exactly 12 inches, so 6 inches. There's center. Where is my color? Color. So what I'm going to do is to make this look better, I'm going to take it in and run it on my belt sander right quick. Okay, I just cleaned up this weld so I'll make it look better, and I put a chamfer on the outside edge, which will allow me to penetrate the bead a little bit better. 4 millimeter. Nice and flat. So all I gotta do is just center that. Well, I want to be able to access the Allen screws from the top. So center it with the screws at the top. A little bit of an optical illusion with the shadows. Okay. I don't think my clamp's long enough. Oh yeah, it is. Just have to not move it. Dang it. Yeah, it's not going to work. It's going to slide. So I'm just going to have to do a little baby tack on it. What I'm doing is I'm blocking the light to get it kind of even shadow in there so I can verify it's in the center. Let's say that boy's on there. Shit, got too close to the screw. Okay, let's see if I can fix that. Tell you what I need is another workbench. So what I did was I got the weld, I tried to put a little itty bitty bead along the bottom of the collar against the plate. I should have backed the power down to C because it got a little too big and up against the Allen grub screw. Oh, that's heavy. Yahtzee! All right, so I've got the back plate, the shaft, the rotating thingamadoo, whatever you want to call it, the wood mounting plate, the mounting collars on the back. So now what I need to do is come out from here and start making the frame structure. So I still have to weld on the all thread on one side of the rotating plate and a base weight. And I got something for that. I can't remember what I got. I think I got I think what I did was, if I recall 6 months ago when I did this, when I placed the order for everything, and I went and got the scrap steel from the drops from Warner Steel, I think what I was going to do was put the 1-inch, I got extra 1-inch round stock. I think I was going to weld a 1-inch on one side, all thread on the other, and have the 1-inch long enough to put small, like 2.5 to 5 pound weights on it, and put a cross pin in it so that I can adjust the weight as needed by putting just, like barbell weights, just the small ones on one side. So as it rotates, when it's got a full roll, it'll have more weight to counterbalance, and I can just pull a pin and then just take a couple weights off and put the pin back in. And I'll have multiple holes for pins, and then I can just put the weights on as needed. And then on the frame, I was going to put a 1-inch piece vertically, like on the back corner, like sticking up from here, so I could just store the weights on it. And just get the weights off Amazon. So now that I've got the overall width 40 1/4 and 36, so that's 1.5 inch steel. If I still want to use the 1.5 inch, and the reason I've got some 1-inch over there, 1 1/4, I think it is. Yeah, I've got some 1 1/4. It's thinner wall, but I'm thinking that I might want to just stick with this 1.5 inch thicker wall steel, because I've got plenty to use for the to come off, and then the verticals. And like I said, the horizontal is going to be these larger pieces for the forklift pockets, and then some front to back 1.5 inch on top of it or in between. I'm not sure yet, but I think if I use the 1.5 inch, it'll be more sturdy, so that it can be bounced around and beat up with my forklifts if I hit something or a piece of wood falls on it or whatever. And then that way, when I go to put some D-rings on it to strap it down to the deck over if I need to, the 1.5 inch, 1/8 inch wall thicker will be able to handle more ratcheting power versus that thinner wall stuff. So I think that's what I'm going to do, because like I said, I'm not going to be hand moving this thing around. I might like drag it out of the way a little bit through the gravel just to move it, but when I'm transporting it, I'll be using the forks on the tractor. Front to back is 35 1/4. So I've got front to back. Let me measure this. So this, let's see, what measurement do I need from here or outside? From here. So that's going to be 7.5. So 7.5 inches from here. So 7.5 inches, and then be another 12 inches. Actually, I want another, what did I say? Man, that worked out great. So I can take this off, because I can just lay it down. So this is all the way back. Okay, so 7.5 inches. Be right there. So this needs to be able to slide forward and aft and be 16 inches at max. So 16 inch, well hell, check that out, 16 inches right to here. So 16 inches is right there. That's placed appropriately. And I should have plenty of space. So that's 12.5 inches, so that's good. So that'll be to where I adjust. I'm going to be able to adjust that all thread, the bolts or the nuts on the all thread forward and aft, so I can get it perfectly in the center. With a 1/4 inch on each side to spare. So that means only a couple inches. So it'll have more wrap on that side. Actually, what I think I'll do is move this back a little bit. So that'll give me 16.25. That'll give me plenty of room, so I can always come in. So let's do 14.5. And then that will give me 13 inches of space. So let me just make that 13 inches right off the bat. And that will give me the dimension. And I'm only doing this to visualize how it's going to look and make sure I get my front to back side brace supports. So 13 inches will give me 1/2 inch on either side of the plastic wrap. And then that will be just under 16.25. And then it will allow me to slide it, well, can't slide it forward. See, that's the problem. That's one thing. I see these wrappers, these bundlers. So let's work this out. I see these bundlers with the ability to slide forward, but the problem with sliding forward is as long as the spin of the wrap, which it looks like it will. Yeah, it'll clear. Never mind. I'm just thinking out loud. And well, actually, I'm correct, because even though this wrap will be right here, it'll clear the top, the sides, and the bottom of the structure here. You can only wrap as wide or as deep, as deep as the plastic roll. So the plastic is 12 inches. Now, granted, you can get some 10-inch, 8-inch plastic if you can find it instead of the 12-inch plastic, but you're limited by the roll of plastic, not by the length of the wood. So if you say, well, I want to make this where it slides front to back so I can put smaller pieces of wood in there, that's great, but your 12-inch plastic isn't going to work because you're going to end up wrapping this right here. You can adjust this forward and back, but the plastic has to clear this overall because you're going to be wrapping this, if not, because it does go over the top of it. So the edge of your plastic, the roll of your plastic, has to basically be able to do this as it stretches, because if not, it's going to hit that. So it'll have to clear that by a 1/2 inch, and it'll have to clear this by a 1/2 inch. And if you bring this in, great, put smaller wood in it, but you're going to have to get a roll of that plastic and either cut it in half to make a 6-inch piece of plastic, or try and source some plastic that's maybe 8 inches long and not the 12-inch long. Because as is, I'm still going to make this to where it slides, in some more, which means I will have to put, this can't be welded like this, it's got to be welded like this. So the arm that comes in here and then comes in there, right, it will have to be no deeper than this, because the plastic's going to, no deeper than this, because the plastic's going to end up wrapping that as well. So it has to be right at the edge of this. So this sleeve that I'm going to put on here with probably a one of these, right? So I can screw it down and then slide it, slide the whole structure front to aft, which is great. It's great if I want to make it to where it's actually 18 or 19-inch wood, but to go smaller for less than 12-inch or a 13-inch piece, it's not going to work, because the 12-inch plastic still has to clear this channel that it's wrapping around. So at a minimum, and that's why I didn't weld these to there, because I have to think this out. So basically, at a minimum, this right here has to be able to probably going to be about, I'm rambling now, but this is my process. So probably about, I want to say, in order to comfortably be able to turn this, 4 inches, so probably about 5-inch long piece welded just like this. So from here to here, 5 inches on both sides. And then the piece that this slides over the top of, dirty. Okay, so basically the arm that comes this way and in is going to have to be made out of this thinner steel, whereas the main frame structure is going to be the thicker steel. So now that I've got that set up, make sure that's 13 inches again. In case I bump it, I'm just going to mark it. Okay, so 13 inches gives me 16 1/4, so 16, and then that gives me in between 12 inches. So the 13 inches in between forward plastic. Good thing about welding table is you can write all over it. Okay, so I got 13 inches in between the inner section for the 12-inch cellophane plastic wrap, whatever it is, to wrap. I know that I need at least 5 inches to get me an appropriate length of sleeve to be able to have the knob on it. So that gives me a grand total 27.5 inches, and I think I put, so it's 27 inches outside to outside. I would rather be able to come in from the front or the back to pick it up, because this will act more like a sled. Okay, so here's why the outer width of my forks is 27 inches. Because if I come in from the side of an IBC cage, it's got to be 27 inches. If I come in from the front, 36 inches is the max width. My Kingspan 114-gallon diesel tote that's got a lid on it and it's got a pump inside, so that's got to be 27 inches. The pallet for my 24-inch auger, 27 inches. So my pallets stay at 27 inches all the time for that reason. 3 things trumps this issue. So if I can get 27 inches out of this, which are 3.5-inch pallets, so let's just say I were to come in 2.5 inches exactly on each side. All right, so if I come in 2.5 inches each side, 3.5 there, 23.5 there, that would be perfect. So what that means is to come front to back with my pallet slots, skids or whatever. I have plenty of steel, so what I can do is I can easily come forward on the furthest outside and then in with 2 1.5-inch pieces of steel, and then when I go down, I'll weld to the bottom. I'll weld starting at 2.5 inches over, so instead of it being on the, so it'll be just like this. I don't know if you can see it or not. It'll be just like this on the sides, but underneath it'll be 2.5 inches in, pointing straight down. So it'll be on the top corner of this skid right here. So the bottom foot will be a little bit 2.5 inches narrower on each side than the top, which will be a full 40 1/4, just so that the assembly that rotates will clear. And then and then same here, 2.5 inches inward, it will go straight down. So that'll give me a nice opening. Okay, and then I'll probably weld from here to here so that it's supported probably in 3 spots. And then this will only be as long as the depth. All right, so what time is it? There's a whole lot of thinking. So what I need to come up with is a dimension that this needs to be 5 inches from there. So that needs to be 13 inches. So 5 inches. And then there obviously needs to be enough room for the weld. So let's add another inch. So let's go 6 inches. So the part that slides over it will be 5 inches. Have an extra inch here, and then it'll basically be able to slide forward to be smaller for smaller wrap. And then this piece is 1.5 inch. So let's add another 1.5 inches. So be 7.5 inches for the furthest outside. And what that gets me is, and I'm working backwards here. I don't want that to fall, so I'll put that battery on there for weight. So what that gets me is 30 inches. So 36 inches is the actual length. And the thing is, I don't want it so deep that I have to be leaning over to put the wood in. So what I want to do is have it just enough so I can just put the wood in and not have to worry about it with enough adjustment going forward, because it's not going to need to be any longer, because the wood will just sit on it if it's longer. Make sure there's no pitfalls here. So I need to cut 2 29.5 inch pieces to go from front to back. So the problem I'm foreseeing is that these welds here will keep me from getting, including on the back, a flat surface. So I'll have to raise that up. Got it clamped above the welds. Still not square, so must be, this plate must be lower over here, or I don't know. A little gap on the bottom. Gap on the bottom. Let's check the front. Oh yeah, that's way off. So I think what I'll do is slide it that way so that I can get this on squared. Okay, so that is square. That is square. So the front plate is what I'm worried about, not the back. The back is just for support. So now what I need to do is rig this up. I think I'll get me some more 1/2 inch. I'll be back. Be gone, fly. All right, so I need to get this raised up the same height as that, and then this on top needs to be a little bit more, but can't control that. But what I can do is clamp it. I'm going to clamp this to that, and it doesn't matter if it's flat or not because it's going to be clamped. Clamped in a hole of all places. I'm like, why is that not moving? Idiot. Okay, so that's clamped down. So I need to raise that up a little bit temporarily. There we go. Okay, so the only way I'm going to get that lined up this way square is to measure. So I can square it up to it, but I can't ensure that this is where it needs to be. Just under 9/16, 3 9/16. That's 3 1/2, so it needs to come up. And you know what? I've realized something again, that when I start having to think too hard about things, and I was just like, oh, I'll just measure it, and no. So I'm going to take my own advice. I'm going to stop for the day because it is incredibly hot out here. I'm completely soaking wet with sweat. It's going on 5. And instead of welding this on there and jalopy adjusting it, I'm going to call it a day. Just leave this set up the way it is and then come in tomorrow after work and maybe work on it for about an hour or two. Or maybe Saturday, depends on how I feel tomorrow, and then I'll continue on, because what I don't want to do is get way too ahead of myself, start welding things together and realize I just screwed up and then have to cut it off. So that'll be it for this video. Fabricating firewood. As you can see, I'm fabricating stuff for firewood now instead of doing French drains. But if you enjoy what you're seeing, please like, share, subscribe, and comment. This video is not, I mean, it's entertaining, I guess you could call it, but this is a video for step by step. That's why I'm not moving the camera much, because I'm more worried about you getting an overall general idea of what I'm doing with measurements. I'm calling out measurements and talking out loud and thinking out loud so that you can get an idea of why I did everything the way I did. But the most important thing is the exact dimensions and measurements while I'm going through it, so that you can kind of go through it as well if you want to, instead of trying to reinvent the wheel. So hope you liked the video. I appreciate you watching. See you tomorrow.